Hello students, my name is Kumari Neha. I am working at Bharathidhasanar Matriculation Higher Secondary School, Arakkonam, and the topic for today which I am going to take is from Chemistry 8th Standard. This is the third part of the lesson, matter. So in the third part we are going to study about the interconversion of matter and what are the different states it's getting converted, right? So before that we should know what exactly is interconversion. So see the definition here, kids. The phenomena of change of state of matter from one state to another state, then going back to the original state is known as interconversion of matter. So here we are going to talk about the three different types of matter: solid, liquid and gases, right. So how the solid, liquid and gases are interchanging, this we are going to study here, right. So first let's go to the first topic here. So whenever interchanging is taking place, there should be two main conditions how the conversion can be taken place. So there are two conditions. One condition is temperature and another condition is pressure. So here in the diagram you can see that if only the temperature increases, a particular type of matter will get converted into gas. Same way, when only pressure increases, then the matter will remain as a solid. Same way, when both the temperature and the pressure increases, it will get converted into liquid, right. So now here let's see about the altering by the temperature, how the things are getting interconverted. So first is interconversion of solid to liquid. So interconversion of solid to liquid, here we can see that now ice is there, this ice is getting converted into liquid. So there is a process which is known as melting. So conversion of solid into liquid is called melting, right. So what it's called, children? It's called melting, M-E-L-T-I-N-G, melting. It is called as melting, or it can also be known as fusion. What it's called as? Fusion. F-U-S-I-O-N, fusion, right. So conversion of solid S into liquid is called melting. Same way, here I have taken the example of conversion of ice into liquid, right. So when this conversion is taking place, the point at what temperature it is getting converted, that temperature is called as melting point. What it's called as? Melting point. So melting point of, here you can see that I can write as melting point as M. P of ice will be equal to 0 degree Celsius. What it is? Melting point of ice is 0 degree Celsius, right. I hope you have understood what is the conversion of solid to liquid. Now we should see what is the reverse of liquid to solid, right. Now see here, kids. Now the interconversion of liquid to solid. So here you can see that ice is there. So from the liquid it's getting converted into solid. So this is the reverse process. So this reverse process is called as vaporization, or you can also call it as freezing. What it's called as? Freezing. F-R-E-E-Z-I-N-G, freezing. It is called as freezing, or one more name is there. Now see, kids, it is getting converted from liquid to solid. It is becoming solid. So you can call it as solidification. What you can call it as? Solidification. S-O-L-I-D-I-Fication. Solidification, right. So now we have seen that it's getting converted. Now at what particular temperature it is getting converted is known as freezing point or solidification point. So whenever I am taking water and I keep it in the freezer, at what temperature it gets converted, kids? The freezing point of water is 0 degree Celsius. So what it is? Here we can write it as F P will be equal to 0 degree Celsius for water. What it is? Water, right. Now let's see the next one. So in the next one, here is interconversion of liquid to gases. So here below you can see liquid. Now because of the heat it's getting converted into gas. So what it is called as? It is called as boiling, or it can also be called as vaporization. What it's called as? Boiling or vaporization, right. So here we can write it as boiling or it is called as vaporization. Now kids, you can ask that why it is called vaporization, because here the liquid is getting converted into vapor. Now when it is getting converted into vapor, it is called as vaporization process. Same way, at what particular temperature it is getting converted is called boiling point or vaporization point. So when the liquid is heated at 100 degrees Celsius, each molecule of liquid will get converted into gas. So here I can write it as the BP. BP is what? BP of water, that is boiling point of water, is 100 degrees Celsius. What it is, kids? It is 100 degrees Celsius. Right. Now this reverse process we have to go. So students, now we will see the interconversion of gas to liquid. So here you can see that already there is ice. Now that ice, if you are keeping in a tumbler, outside there will be some type of gases. So here gases, now you can see that small droplets are coming, right. So here the cold gas, it's getting converted into liquid. So this is called a reverse process, right. So in this reverse process, how you can call it as? This process is known as condensation. What it's called as? Condensation. C-O-N-D-E-N-S-A-T-I-O-N. Condensation, right. So this condensation can also be known as what, kids? It can also be known as liquefaction, same as solidification. There solid was forming, right. So here liquid is forming. So this is called as liquefaction. L-I-Q-U-E-fication. So now again we will talk about the temperature here. So at what particular temperature this gas is getting converted into liquid is called condensation point. Here we will not discuss about what the temperature it is getting changed, but the temperature at which a gas gets converted into liquid is called condensation point, or you can call it as liquefaction point, right. Now we have to look at the different file. So here now we will talk about how the solids get converted into gas directly without changing into liquid. So here you can see that first white color particles you can see here, right. Now automatically after some time this all gets disappeared. So here this solid gets directly converted into gas without changing into liquid. This process is known as sublimation. What is known as? Sublimation. S-U-B-L-I-M-A-T-I-O-N. So sublimation is a process in which directly solid will get converted back into a gas. It will get back converted into gas. So the name of the process is sublimation. So here we cannot talk about the temperature at which it is getting changed, because there are various forms in which it is getting changed, right. Now we have to see the reverse process, that when the gas gets converted into solid again. So here let's see this. Now here you can see a plate is there, right. So at the corner you can see the month's name. So previously you will see that the whole plate is clean. So if the plate is automatically full clean, then it is the pure metal. See here, now a little bit it's becoming brownish, right kids. Now this is becoming brownish. Why? This is becoming brownish because it is getting contact with the atmosphere air. That is why that gas is directly getting converted into solid, and this solidification here, the brown color, is known as rust. What it's called as? It's known as rust. R-U-S-T. And the process in which it is getting changed is called rusting, right? So here that brown powdery particles are formed, so that is known as rust, and the process of becoming a rust is known as rusting. Same way, now this process of changing of gas directly into solid without getting converted into liquid is called sublimation. S-U-B-L-I-M-A-T-I-O-N, sublimation, or it can also be known as deposition. D-E-P-O-S-I-T-I-O-N, right? So you can ask me why I am calling it as deposition, because on the flat surface there is small particles, that is brown color particles, getting accumulated, deposited. That is why this process is also known as deposition, right? So now we have talked about how the temperature change in the matter is brought out, right? Now we should discuss about when we are altering the pressure, how the pressure, or you can call it as matter, is getting converted. So there is one main point. When the pressure is lowered, the boiling point of the liquid is also lowered. So students, what we talked about this boiling point earlier? So boiling point is a particular temperature when a liquid is getting converted into gas. So when liquid is getting converted into gas, at that temperature is called as boiling point. So here there is an example. So here there is a pressure cooker. So boiling point of water is 100 degrees Celsius, right? Now when I put water inside the pressure cooker and I close it, that time you can see, listen the whistles, right, in your home when your mother is cooking anything in the cooker. When they are cooking like this, you will hear some kind of whistle from that, right? So that whistle, why it is coming? Because the pressure inside the cooker is so high that still the water does not get converted into a gas. So here we can say that if the BP, what is BP? Boiling point is high, then you can call it, then it will have the pressure also very high, right students? Pressure increases, the boiling point will also be increased. Pressure decreases, the boiling point also will be decreased, right? Now we have talked about how the pressure is getting changed. So there are two main factors. Now you can ask me, what is the difference between a gas and a vapor? Both is the conversion, right? It's the conversion from liquid to gas. So here you can see this is called a steam. Steam is a kind of gas. Same way here you can see vapors of fire is coming. So there is only small difference between gas and vapor. So gas is a temperature which is equal to or more than the boiling point of that particular liquid. So the temperature will be equal or it will be more than the boiling point, right? Same way here when you are taking, here the temperature of that particular liquid will be always less, You can call it as temperature is always less in the case of water. So here I am taking water. So when water I am taking, the boiling point is less, then it is remaining as a vapor. Same way here I have given the examples. Oxygen, hydrogen, carbon monoxide, these all are gases. Same way water vapor, alcohol vapor, all the watery kind but still air, they are vapors, right? So now what is the use of change of matter? So first here you can see a petroleum industry, or you can call it as a thermoelectric power plant. So in this they are using steam for production or more good manufacture of any kind of particles or ions to generate electricity. So, this is what kids, this is thermoelectric power plant. So, next here you can see that this is a glass, okay. When you are heating a glass, that time you can shape it. That shaping is called as molding or smolding. When you are changing the shape, the change is entirely getting converted, right. So, this is also a perfect example for change of state. Here spray, the spray is in liquid, but when we are putting it out, it comes as gas. And last is melting of glacier. When the melting of glacier is taking place, the level of water will increase. If the level of water increases, then it can be beneficial in some cases, it can be very bad in some cases, right. So, let us come to the last topic. So, here in the last topic you can see that the law of conservation of mass. So, law of conservation of mass was discovered by Anthony Lavoisier. So, what he said was, according to this law, the mass can neither be created nor be destroyed in a chemical reaction. That means when you are cooking something, how much weight you have taken initially, the same weight will be there at last also. For doing this, we are going to do an experiment. So, in this experiment, we are going to use silver nitrate, hydrochloric acid, beaker and weighing balance. So, in this experiment, here you can see that this first position I have taken two liquids. Here one liquid is HCl and another liquid is AgNO3. So, HCl is hydrochloric acid, AgNO3 is silver nitrate. When these two are colorless liquids, right? Now, this colorless liquids, when I mix it, you will get a curdy white precipitate. This is called a curdy white precipitate which cannot be dissolved. So, when it is not getting dissolved, it is called a precipitate, and this is AgCl plus the remaining part is H and NO3. So, here we can write it as HNO3. HNO3 is what kids? It is nitric acid. So, here below you can see the equation I have written. Here what happens, how much weight I have taken initially, that is 92.95 gram. After mixing also, after getting the new products, the weight is exactly same. So, this proves that the law of conservation of mass will take place at each and every point, right. So, students, today in the class we have discussed about how the interconversion is taking place. Now, this interconversion is solid to liquid, liquid to gas and gas to solid back again, right. After that, we have discussed how the pressure is increasing, the boiling point also increasing, and last we have talked about the change of no particular ornament, or you can call it as amount, the mass. The law is law of conservation of mass, right. So, students, I hope you have enjoyed the session. After finishing this video, you can go through the YouTube links or you can go to the subject material which we have attached down. After that, after reading everything and going through the YouTubes, you can go for the self-assessment, right. I hope you have enjoyed the class. Bye-bye.